Lead, it affects practically all systems of the body. It's a powerful neurotoxin. It really inhibits your development of your brain and central nervous system. It can really start impacting your cognitive function, like your memory, attention, fine motor skills, and other things. Radioactive substances, a lot of the big problem with them is they spontaneously emit radiation. They come from mining and processing of radioactive materials. Thermal pollution, what it refers to, thermal, it obviously relates to temperature. So thermal pollution is a pollution of temperature. So it's the adding of really warm things to an area or really cold, really dramatically changing the temperature of a body of water. It's produced during industrial processes, so a lot of times coal burning power plants, they'll use water in order to cool a lot of their machinery, and then in the process of cooling that machinery, they'll actually warm up the water. This hot water is then just dumped into different areas, so it warms up waterways and watersheds. And it can cause chemical reactions to speed up and just adversely affect a lot of populations that exist in those watershed ecosystems. So one of the things that it can really do is it can actually lead to the decrease of dissolved oxygen. So as you can see in this table, as the temperature is increasing, the amount of dissolved oxygen within the ecosystem is going down. So this increase of temperature caused dissolved oxygen to go down, and as you should know from listening to this video, dissolved oxygen is very important within marine ecosystems. So moving on to water quality today. Water quality today is really negatively affected by two types of pollution. Water pollution is broken up into two things. It can either be point source pollution. An example of that would be like a cyanide spill. So point source pollution, it's pollution that occurs through the dumping of pollutants out of pipes, sewers, ditches, or other specific sites, such as factories or sewage treatment plants. The main thing that you want to focus on when identifying point source pollution is where did it come from? If it came from a specific spot, like a point, like one area, that's an example of point source pollution. The other type is non-point source pollution, and what that refers to is land pollution that enters bodies of water over large areas rather than through a single point. It occurs when precipitation moves over or through soil and is carried to a wetland and or other body of water. So some examples of that would be fertilizer runoff from agricultural fields. So this fertilizer, as it's used when growing crops, it eventually is carried off through precipitation. This precipitation then joins up with other waterways, kind of like we illustrated with the Mississippi watershed just a minute ago. Now, water pollution from agriculture causes 72% of all water pollution. Chemical pesticides, what they do is they leach into soil and then that can come into water. We already talked about the problem related to fertilizers extensively. Soil erosion from fields can also occur, and rangelands, and it can cause sediment pollution in waterways. Municipal water pollution, this includes urban runoff. Urban runoff from cities, streets is often worse than sewage as it contains salt from roadways, untreated garbage, animal waste, construction sediments, and traffic emissions. This type of waste is usually treated at a sewage treatment plant. However, sometimes in cases of large storms, sewers overflow. So what happens is when you have a huge storm hit an area, this entire sewer will fill up, and once it's full, it's full. It can't really go anywhere else. So then the storm drain will overflow and water will go essentially everywhere. Industrial water pollution, the problems really depend on the industry. Food processing, it leads to high BOD, biological oxygen demand. Paper mills, they can lead to toxic compounds and sludge. Many U.S. industries now treat their own wastewater. However, a lot could be done in terms of improving that process. One thing that a lot of scientists are focusing on right now to improve that process is green chemistry. Green chemistry, it aims to minimize environmental impacts uh, and was developed in order to combat pollution. Green chemical practices would include using fewer synthetic chemicals, using silicon-based cleaners instead of hydrocarbons, and replacing harmful synthetic cleaners with less harmful alternatives. On to the issue of groundwater pollution. Now, this chart, it actually gives a really good representation of different ways that pollution can enter groundwater, such as nitrates and pesticides. They can seep into the ground and then eventually end up in your aquifer. If you have different things that are stored underground, such as gasoline storage, septic tanks, all those things, they eventually crack, leak, something ends up happening usually, and as that happens, the chemicals that are stored inside them, they start to seep down into the groundwater. Okay, so now we're on to the purification of drinking water. It's a general process. Essentially what happens is water is collected, so right here it would be stored in a reservoir, and it can be either acquired through reservoirs or through groundwater, so using a well. After it's acquired, it goes to a water treatment for consumption. So what it does is it filters and chlorinates the water, so it goes through the process of purifying it. After it's purified, it's then used in homes, factories, and businesses, and it goes in those places, and then it comes out through sewer lines. And these sewer lines, they all eventually meet up, and then they head out to the sewage treatment plant. So the wastewater, is treated through primary and secondary and sometimes tertiary treatments in order to clean the water. And this cleaned out water is then allowed to re-enter waterways. So related to the purification of water, there's a few issues related to that, and they mainly relate to chlorine and fluoride. So chlorine is a chemical that is added to water in order to treat and kill bacteria that's present within the water. So it sanitizes water through killing disease-causing organisms. The real big downside related to it is the use of chlorine can be linked to birth defects, cancer, and other health issues. However, the amount of lives that have been saved through the use of chlorine, most scientists would consider that more of a benefit than the cons related to it. So it's a process that continues to happen. That's same with the fluorination, and fluoridation, it refers to the adding of fluoride to water, and fluoride, it's something that's found in your toothpaste. It's used in order to fight tooth decay, so the water you drink actually helps keep your teeth strong. However, critics of that say that it may not be the safest practice. So again, a debate continues on whether that should be continued to happen. However, a lot of states are still, like even as recent as 10 years ago, passing laws related to adding fluoride to water. So the trend is more to add than take away. As far as municipal sewage treatment, what happens is as your raw sewage water enters a sewage treatment plant, it has its sand filtered, usually by use of a screen. There's a primary sludge filter. Those are both part of the primary sewage treatment. So what they're really trying to do is get any sand out of it, and then any really big chunks of matter they're trying to remove, and then that would then be digested. Anything that makes it through primary sewage treatment will make its way to secondary sewage treatment. So in secondary sewage treatment, bacteria is used in order to further break down and treat the water. The sediments are then allowed to resettle. This is all in hopes of trying to remove more and more sludge from the water. After all that's done, the water is then treated and disinfected using chlorine, and then it's allowed to re-enter lakes, rivers, streams, and oceans. So, as part of municipal sewage treatment, this chart is showing the effectiveness of different treatments related to sewage treatment. So here is primary treatment. So primary treatment, it really gets rid of sewage, solids, and it starts getting at pathogenic bacteria. Pathogenic means disease-causing, so those disease-causing organisms. Secondary treatment, it really starts having an effect with the dissolved organics and viruses. It doesn't really get at nitrogen or phosphorus. Tertiary treatment, it's an additional treatment that can be done. It's typically used in more rural areas or water poor areas. So where water is scarce, they use tertiary treatment, because then the goal wouldn't be to put it in some watershed, it would be to actually reuse for drinking purposes. So that really starts to get rid of the viruses and nitrogen and phosphorus. Chlorination really finishes off the process, eliminating anything that's really left in the water. With municipal sewage treatment, some major problems associated with wastewater treatment is the disposal of sludge. We have all this going on in the removal of sludge, but what's done with the sludge once we have it? It can be used as fertilizer, but there could be some heavy health risks in that heavy metals could be present within it, which can cause to lead poisoning and mercury poisoning. So it can be a bad practice. Other times it's used to dump into the ocean, and right now that's banned. So currently most of it's being dumped in landfills, so these are ending up just at your regular trash landfill. On to individual septic systems. Right here we have a septic tank that's being illustrated. Right now what happens is household water, it goes into the septic tank. Scum, which is oils mainly. There's a few other things that make up some grease. They separate at the top, and bacteria is used to treat those things, so break that down. Wastewater forms a layer underneath the scum, and this wastewater is allowed to drain out into a drainage field. At the bottom there's the settling of sludge, that sludge again, and it's about once every 5 years you're supposed to get your manhole cover taken off and your sludge removed, because that sludge is just building up at the bottom of your septic tank. Septic tanks, at least individual ones, they're more used in rural areas as opposed to urban areas, so I doubt this is anything that you all have come across. This is how it would look hooked up to a house. Right here I have wastewater from the house, it's going into the septic tank. These are then allowed to drain out into my drainage field. So, moving on to laws controlling water pollution. The Safe Drinking Water Act, it set maximum contaminant levels for drinking water. That was passed in 1974. The Clean Water Act, it was in 1972. It pertained to improving quality of rivers, lakes, aquifers, estuaries, and coastal waters. It reduced direct pollutant discharge into waterways, financed municipal wastewater treatment facilities, and managed polluted runoff. Some examples would be related to the Great Lakes. I have some links. You can click on them. Laws that protect groundwater. The Safe Drinking Water Act, it was amended in 1986 and 1996, and many of the actions were done in order to protect drinking water at its sources, so rivers, lakes, reservoirs, springs, groundwaters, and so forth. And the next was the Resource Conservation and Recovery Act. It was enacted in 1976 as a principal federal law in the United States, and it governs the disposal of solid waste and hazardous waste.